So our last speaker of the afternoon is actually my colleague, Shen. Dr. Shen is an assistant professor in the Department of Economics here at Davis. She earned her PhD at the University of Texas, Austin in 2011. She's an econometrician, and her research focuses on developing new statistical methods to unveil and quantify heterogeneity and the impact of policy treatments. She specializes in statistical inference for problems involving multiple comparison, developing methods motivated by academic reproducibility. Besides theoretic work, Dr. Shen is currently working on a big data project that quantifies the degree of data manipulation in the air pollution index in China and links the manipulation behavior to economic and political factors. In addition, she's also on the board of directors of the Chinese Economist Society this year, and so we're interested to hear about some of her research.
Thank you, I'm the last speaker, so thanks for coming and staying. I'm having a hard time to link my topic to the theme of the panel. So you can think about it as if you manipulate data and publicize it, it probably will get caught sometimes in the future. Or more broadly, I would think that it's a reflection of as economists and social scientists, when we are doing research using self-reported data, oftentimes we need to use self-reported data about, say, education or income or SAT scores in some surveys, or we need to use economic, environmental measures self-reported by the government. Some data series are more problematic than the others. Now, so sometimes it's helpful before go directly into using this data to try to take a peek at the problem of these self-reported measures and to think about the root of these manipulations behind these self-reported data. Okay, so particularly I'm going to talk about the air quality data in China, and the incentive and for manipulation of that data set. So there's rising awareness of this air quality problem in China. And the central government actually always have this good view to curb air pollution and basically provides some incentive for the local governments to manipulate the data. Starting from year 2001, local government need to publicize daily air pollution index, and a day is called a blue sky day if the index is below 100. And starting from 2006, this proportion of blue sky day enters the formula to evaluate the performance of local governors. Okay, so if we just look at the data that government is reporting, this is the graph for Beijing, but we can see this trend for almost every of the cities. There is a monotonic increase in the proportion of blue sky days. If we take the data seriously, you might say, okay, and then I know the New York Times must be exaggerating things. Things are not that bad. Pollution is getting better. So, but as government is reporting data, actually the citizens in China is also watching the air quality. So they take picture of the blue sky days. Some days are more blue and some days are grayish, like this day. That reminds me of some of the days last summer when we had this forest fire in Lake Berryessa, right? Looks very similar. So what's the problem here? So how can a blue sky day be so grayish? Okay. So to understand that, we first need to look at what the index is being used. The index used in China in that period of time is air pollution index that has only previously been used in Indonesia, mainland China, and Hong Kong. And it's constructed based on only 3 pollutants, SO2, NO2, and PM10. Now, in the States, we and most of the other parts in the world, the index used is the AQI index, which have a similar taste and similar formula, but relies on some more pollutant concentration sub-indexes, including ozone, PM2.5, and carbon monoxide. Okay, and in the US, the people figure that the more binding pollutant is PM2.5. We are more worried about high concentration of PM2.5, and there's this Novan rule here in Davis, basically worried when a day that is predicted to have a too high PM2.5 concentration, we are now not allowed to burn fires at home, fireplaces, okay? So if you compare these two indexes, probably we will conclude that the grayish blue sky days could come from the unreported PM2.5, okay? That could be a possibility. Or if we look at the data closely, it could come from government manipulation, maybe. This is just pure histograms, and, and this is 2001, 2002. Now, if you look at the histogram from 2006 and the 7, you see these big spikes. These are the proportion of dates falling into API 95 to 100. Okay, so obviously they are manipulating, bringing back the APIs to just below the cutoff to make it a blue sky day. Okay, and things get really worse when this proportion of blue sky day enters the formula for the performance evaluation of these local government officials. Okay, so 2004 a little bit cheating, 2006 a lot of manipulation, 2008 it's Olympic, it's a little better, 2010 it's bad again. Okay, now if you put the data to a statistical test to look for whether there's discontinuity in the distribution of this API index around the blue sky day cutoff, it's very easy to reject non-parametrically that the distribution is continuous. Okay. So there's very strong statistical evidence for manipulation, and this is for Beijing. And actually, my co-authors, Dahlia and Junjie, they did a previous research that found that basically 50% of the cities manipulate the API index. Okay. So the research question that we are going to ask in this project is what's the magnitude of this manipulation in the API index? Okay, and then can we back out the unmanipulated blue sky days? And the second question we want to ask is, early on we see that there's this big hike of manipulation around 2006. So that's indicating that the political factors probably matters in people's behavior of manipulation, okay? So we want to do a big data analysis and try to see whether we can link this manipulation behavior to any economic, environmental, and political factors. The data we have, first of all, air quality data, 111 cities for 10 years. We have the publicly available API data and some confidential pollutant concentration data that are used to construct the piecewise linear API data. Okay. And then we have a lot of economic and environmental factors coming from the city yearbooks. And we have one for RS. That helps us to collect a lot of political factors about these local government officials and collect the factors from their resumes. So we completed the data set for City Party Secretary, and we are still working on the data set of city media. It's probably a little bit difficult to understand the concept of city party secretary. Basically, there are two leaders in a given city. From leader to party secretary, it's considered a promotion.
I think they're having a hard time hearing you in the back.
Oh, okay.
Speaking.
Sorry about that. So probably you can think about as the dual leadership of chancellor and provost. Maybe that will help. So first question, how much do they cheat? What's the magnitude of manipulation? We have three measures. The first is the percentage change in the PDF of PM10 concentration. So that's the similar measure that we have seen earlier for the non-parametric test of continuity of density. So we are looking at the percentage change of the density from this point to this point. The advantage of this measure is that this is a fully non-parametric measure of the magnitude of manipulation. So this advantage is that this jump actually depends on where this blue sky day cutoff is at the distribution of this PM10 concentration. Okay, so it's probably not very intuitive. So to construct some more intuitive measures of degree of manipulation, we also use some parametric estimation method to back out the counterfactual distribution of this API index or the concentration index of pollutants using the censored MLE method. So the idea of this method is from here. Now, if we fit the data to a parametric class of model, but if we observe a data that's reported to be 98 of the API, we're not sure whether this is the truth or not. So we don't give it the exact likelihood. We say that probably this 98 data comes from an interval between 98 and 120. Okay. But if we observe a data that's like reported API around 50, we say, okay, that's it. There is no manipulation here. Okay. So using this method, we will be able to back out the counterfactual untreated distribution. And typically in a year in the beginning where there's not a lot of manipulation, and in this year 2008, there's not a lot of manipulation. And the orange line and our estimates will trace the data very well. But in years where there's manipulation, you will see this delta here. Between the data that we observe and then the counterfactual distribution that we approximate, that will help us back out the magnitude, how much they manipulated, okay? And with that, we will be able to construct a counterfactual unmanipulated blue sky days. So early on, we showed this green line, this monotonic increasing trend of blue sky days, but if we put it into our estimation method, we'll find that actually the air quality doesn't get better before the Olympics, okay? Then it's only when 2008, we have the Olympics and a lot of factories are shut down and or permanently moved out of Beijing, this air quality get a lot better, okay? And here we see that actually 15% of the blue sky days reported in 2006 and 2007 are manipulated. And if you you see a reported API index that's 99 or 11, more than half of the chance that's manipulated. Okay, so that's the first question. Now the second question, we did use this exercise to figure out the magnitude of manipulation for all of the cities. And then we want to figure out the link between this manipulation behavior and the economic, environmental, and the political factors, okay? So we have just so many variables to use, and we don't have any prior knowledge of what could affect the manipulation behavior, so we did a big data method, Lasso. And Lasso, and basically we threw all of these variables into our regression, and Lasso is going to spit out the variable that it thinks is important. So it spits out the initial status, percentage of days above the cutoff in the first year, and it spits out some interesting interaction terms. So a specific group of cities that's called important big cities, and interacted with 3 of the party secretary features, that is whether he's also a member of Provisional Communist Party Congress, whether he's a minority, and whether he received education during Cultural Revolution. Okay, so the economic and environmental factors does not enter, But then when we take a second thought, if it has any effect, probably it's going to be a small effect, and the lasso is going to trim away all the small effects. And another explanation probably is that, I mean, these economic data probably are manipulated and noisy as well, so it's very hard to get a link out there, okay? So, so we have these variables selected by the big data method, so we can do a post lasso to regress these outcome variables on the variable selected. But that is a little bit not intuitive. It's not very common in social science to have interaction terms entering your regression, but not having the levels in there, right? So we decide that we are going to bring back the levels. That has costs. We lose statistical precision a little bit, but we are more comfortable of doing things that we think are right. And we also controlled provision dummies and the year dummies just to be safe. And the cluster standard error at the city level, and here's what we found. We lose statistical precisions in some of the variables, but that means that we think that the results, what we are finding here, are really very strong, okay? So what we are finding here is initial conditions really matter. If the city has a lot of air quality problems in the beginning, it's more likely that there will be more cheating behaviors later. Now, this type of city is important, and I will explain. And the interaction term between whether you have a minority government official interact with this specific type of city is important. Okay, so why is that? The type of city that's important is called important big cities. These categories are not made up by myself. So these are corresponding to the specific rankings of the city that's embedded in the political system of China, okay? So from each of these cities, mayor from small city to big city, it's considered a promotion. And from the important big cities to metropolitans like Beijing and Shanghai, it's a big promotion. It's not only a promotion, but it also extended your political career. So if you are in these three local government officials in these three groups, your retirement age is 60 for male and 55 for female, okay? But if you get a promotion from this point, entering here, or ministers of the central government, your political career is added by 5 to 8 years. Okay, so there's huge incentive there for manipulation. And okay. Oh, and how to read these graphs? The orange bars represent the proportion of days that have reported API between 100 and 105, and the blue bars correspond to the proportion of days that corresponds to reported API 95 to 100. Okay, so if you see the skinnier this orange bar is compared to the blue bar, it's more evidence of manipulation, okay? So we do see, I mean, we have our lasso results, and then we go back to the data, we do see supportive evidence from the data that there's more manipulation behavior probably for this category of cities, okay? And if we zoom into the minority local government officials, we see that really, they cheat a lot, okay? So, and we will explain that as they have more incentives as well. So as I explained earlier, starting from important big cities and get promotion, you get more years in your political career. And because of this, because in central government, most of the officials are male and ethnically Han. So if you are either a female or an ethnic minority, your political career probably is more promising. You just for diversity purposes, you get it's easier for you to get promoted, and you have bigger incentive just starting from here. Okay, so that's all I have for this data analysis project. Yeah, thank you.